Okay, so just a little kind of 411 on the rest of the semester. Homework, written homework 4 will be due Friday, May 3rd. So it's kind of late. I will have it graded and give it back to you on that Monday. That Monday is a review, so let's just kind of pop up the calendar real quick. Monday the 6th is a review for Exam 4, which Exam 4 will cover those sections. So then you'll come on Tuesday, the 7th, which is a little different, right, because you're used to taking exams on Thursday. But you'll come in here on Tuesday and you'll take Exam 4. I will grade that and give it back to you on Wednesday. Wednesday will be just kind of a review and catch up for the final exam. And then Thursday and Friday are reading days. So the School of Arts and Sciences has a policy for do not hold class on Thursday and Friday. That's for the students to seek out resources to study for the final exams. Saturday the 11th is your final exam. It will be from 10:30 to 12:30, probably in 111 Royal Hall. Don't quote me on that because it's not set in stone, but that's where it's been the last 2 times. But you will get an email as we get closer telling you exactly where it's at. So this doesn't give us, this last week is busy, right? Review for an exam, take an exam, review for a final, and take a final. So it's kind of hectic week. So kind of enjoy this next week and next 2 weeks because this last week for calculus is pretty intense. We're the 23rd, we're here. We're going to go over for you guys I kind of didn't go into 5.5 in as many details as I wanted to, so we're going to touch a little bit on that today. And then we'll go into a little bit of 5.6, and then we'll go into 5.7. So we'll kind of catch up on 5.5, 5.6, and begin 5.7. And then on Wednesday, I don't think we'll have a problem finishing 5.7 and 5.8. 5.7 and 5.8 are the exact same concepts. One is specifically with rectilinear motion, and one is just the average value of a function. What's the average velocity? Well, you integrate velocity over the time interval and divide by the time interval. What's the average value of the function? You do the exact same thing. So really, 5.7 and 5.8 conceptually are the same, what they call it, function or specifically velocity. So I don't think we'll have a problem getting through the material today and tomorrow. Thursday, I'm actually going to be going out of town, and I originally said, okay, well, I could get a sub for you guys, and you can take your quiz and then go, but since I'm not going to be here, the majority of you probably don't want to be here either, so I'm going to put the Wiley quiz online. So this is quiz 9. Quiz 9 will be online, meaning it will replace your lowest quiz score. So any quiz we do from now on out, theoretically it's optional, but you want to take it to replace your lowest quiz score. So the class will be online, so I'm not canceling class, I'm moving it online. And it will cover 5.2, 5.3, and 5.5. So the same, you guys took a Wiley quiz when we had the snow day. The same concept. You'll have 3 tries. They won't change. The first 2 tries you'll get 100% of the points. The problems won't change, so if you realize, oh, I should have put a negative there, I can fix that, you'll get your full points for the quiz. And then the 3rd try, you get half the points. And Wiley will take your best attempt. So if there's 4 points possible on the first problem and you get 3 of the points, and the next attempt you didn't get that one you got wrong, so you get 3 of the points. And that last attempt, say you got it right, but you only get 2 of the points. So Wiley's going to take 3 of the points for that problem. So that will be on Wiley, and I'm going to open it after class on Wednesday. So it will be scheduled to open after class on Wednesday, and you have until Sunday at 11 p.m. to take it. So it's a little different because usually it's due on Monday night. So just know you need to take it by Sunday at 11 p.m. Question?
I mean, you don't have to go into detail on this. Just if they have a question on the final about like the revenue or net profit or whatever that problem was, are we gonna
maximum minimum problem?
Yeah, are we gonna have to know the equation, or is that
if they have an application problem like that, they would give you the equation for profit,
Okay.
being revenue minus cost.
Okay.
And then they would give you those individual functions. Yeah, they don't expect you to pull too much out. Area of a rectangle, area of a square, area of a circle, things you know. But other than that, they give you pretty straightforward what you need to solve the problem. Question?
Does the online class on Thursday entail anything beyond the online quiz?
Originally, I didn't know how far we're going to get this week. So if we needed to lecture, I could lecture in this setting and post that online. So I'm going out of town Wednesday evening, so I would just, whatever I needed to, I would lecture on it and post it. But I don't think we're going to need that. And originally on our schedule, it was just to take a quiz anyways. So there was no extra lecture to go with that. It was just kind of a catch-up, answer questions, take a quiz type day. So it's just going to be a quiz.
So there's no class on it? Or there's
It's on-
So I don't. So basically, what I'm saying is I don't want to say it's canceled. I'm saying it's online, and the class being online is to take the quiz. I will send out an email
Just like we did
saying,
last time.
just like we did last time for the snow day.
Quiz class.
It was just a quiz class.
Okay.
Yeah. So
So technically it's online.
Yeah. Exactly.
Do you still plan on going through a final and posting a video about that, or?
Yeah, I'm working on doing that. Probably next week it will be posted. So yeah, work through a final exam, explaining pitfalls where students go wrong, and seeing it do that in that atmosphere. So yes.
I know the answers are out for the finals, but there's like no work, right?
There are work, yeah.
Oh, there is.
I think there's 4 that have solution manuals or solutions set to them that has the work step by step what you would need. Some of them actually have a point distribution as well, but I think only one of them has that, where you say 4 points for this, 5 points for this, 10 points for this. So you can look at those. Yeah, and I would tell you guys, kind of suggest that you do that. Some of the other instructors had mandated it and say you print these off and work them through and turn them in, and I'll give you points for that. But I mean, it's your benefit to do that. So, and the answers are posted on Blackboard anyway, so copy them down and turn them in. It's, I don't know. I don't want to force you guys to do that. I don't want to force to be looking at it and give you points for it. So I would suggest you do that though. And the reading days, in the past, these 2 reading days, I'm not supposed to hold class for. And I've had students say, "Oh, but can I come and work through things?" So what I've done in the past is I've been in the ILC, which is not in the classroom, away from campus. It's in the 4th floor of the library, and I brought a stack of old final exams, and I just, whoever wanted them could take it, and then for 2 hours you could just pretend like you're in the final on Saturday. So sit down, say, I have my calculator, my pencil, that's all I have, and try to take it. That will kind of psychologically put you through the mindset of, okay, I got this, or no, I need to study this, because I don't want to blank on the final exam. So you can blank in the ILC, and I'll be there to kind of support you. And generally, we've also invited every other Calculus 1 student, and so you'll have Calculus in other courses. So then you guys can kind of work together or talk to each other and work through it together and get that feedback. Okay, I understand what I'm getting myself into on Saturday. So there will probably be a date. I haven't set a date yet. I have to make sure the ILC is open and they're not having classes, or they're not holding a review section for college algebra at that time. Generally, I've done it from 10 to 12, which is my class time, 10 to 11, 11 to 12. So it'll probably be something similar to that, probably on Thursday or Friday. And then you take the exam on Saturday. So it's kind of the last crunch time to make sure you know where you're at. Did that answer your question, or I don't even remember what your question was? I just wanted to get that out
If
there.
There was work on that, but yeah.
Okay.
So if you do a video of you going through finance,
Mhm.
will you do one that doesn't have the work on it? 'Cause there's only like 4 that have work on it.
Okay.
And then,
Yeah, I can do that.
And then there's like 6 or so that.
Haven't, been
Yeah.
posted. Yeah, that's fine. I'll try to do that. All right. So last couple of times, I have kind of said, okay, 5.5. 5.5 is a section that's very limited in what you can do. So if we look on Wiley, let's go to your view, or let's go to your assignments. Here's our section 2. So with the other class, I worked through 5.5. And we did this one in class, right? This is where I left off. The absolute value, I graphed it and said to find the area, you add the area above the x-axis and subtract the area below it. This is an example of net signed area. Net signed area says the area above the x-axis is positive and the area below it is negative, right? So what is the area from A to B? 0.8, right? 0.8. What is the area from B to C?
Negative 2.
Negative 2.4, right? What is the area from A to C?
So you subtract
Negative 1.6.
1.4.
Minus 1.6. So you see that if I take 0.8 minus 2.4, I get minus 1.6, right? This is this idea of negative, or this is the idea of net signed area. Fundamental theorem of calculus takes this into account. If I'm integrating from A to C, and I have a function, and I find the antiderivative, and I plug in the upper bound and lower bound, it will give me negative 1.6. I don't have to do anything above that. But in 5.5, I'm just getting the area from a graph. So I have to make sure that I'm taking the area above the x-axis as positive, the area below it as negative. Does that make sense for net signed area? This next one is pretty straightforward, and it shows you that those properties, if I add two functions together, the integral of two functions, I can break up the integral of one function plus the integral of the second function. And the constant times a function can be rewritten as a constant times the integral of the function. So the integral of f of x from minus 3 to 4 is 3. So this can be replaced with 3. Plus 3 times minus 8. Right? Because the integral from minus 3 to 4 of g of x, so it's going to be 3 times that integral. Right? So it's similar to what you guys did with limits. If you guys remember back in the day where I said, oh, I know the limit, and then what's 3 times the limit? So this one is probably the most difficult one on this section because it involves completing the square. You have to complete the square, graph this, which is it's going to be a circle. This is a Calc 2 integration, which is the trig substitution in 7.8. You won't get to this until you get to Calc 2 on techniques of solving it. So the only way you can do this now is by doing completing the square and graphing it and rewriting y minus h squared plus x minus k squared equals r squared, which is a circle centered at hk with radius r. So I think we'll have time to work that one through. This one you're graphing. This is a 4x plus 7. So if I want to find this area, I can graph it and then use geometry. 4x plus 7 is a line that goes through the y-intercept at 7 with slope 4, and I'm finding the area underneath that from 0 to 3. Right? And then continuity has to do with being continuous and differentiable at the same point. So if I plug in 0, I have a problem. But the limit from the left and the right approaches 0, so this function is integrable over this integral. Because the limit on the right and the limit on the left equals 0, and the value of the function at the point equals 0, right? So here, in this example, you're going to go about the same thing. Okay, so here it actually tells you this in the word. A function is continuous if it's integrable. So if f has infinitely many discontinuities but is bounded, then it's integrable, and if it's not bounded, then it's not integrable. So cosine of x from minus 1 to 1 is integrable. It's bounded, right? And it's continuous. This function is actually not integrable because if you take the limit on the right and the limit on the left, you get 1 and minus 1, right? So this one would be not integrable. Here, is this... sorry, this function's not bounded, right? This is going to 0, but it goes off to minus infinity. Or sorry, it goes off to infinity. So this one is not integrable on this over minus 1 to 1, yeah, because 0 is included on that. So it's not bounded. This function just goes off to infinity. So it's not integrable. And then sine of 1 over x, as x goes to 0, sine goes to infinity, but it's bounded, right? So this would be integrable. From minus 1 to 0, I have a problem at 0, but the value of the function is 0 at 0. So I'm taking sine of something that's going to infinity, so it's bounded between plus or minus 1, right? So the function is bounded. So those are pretty straightforward. Let's check to see. And this is the one that is integrable. From minus 1 to 1. Okay, so it has finite many discontinuities. So it's not continuous, but it's integral because it's bounded. From 1 and minus 1, right? So it's still bounded. And if it's bounded, then it's integrable.
Well, how can it be minus 1 though if it's the absolute value?
Because x on top is not. So the bottom's always positive. So if I approach from the left, it's minus 1. If I approach from the right, it's positive 1. So yeah. So this is minus 1. The limit doesn't exist at this point, x equals 0. But the value of the function is 0. So it's bounded, though, by plus or minus 1. So this is not integral because it's not bounded. But the limit on the right equals the limit on the left. So here this function is bounded, so it is integrable. And I believe the ones you have here are the same on that. And that's more of a conceptually what's it mean to be able to integrate something, and you won't really be asked at the level, is this function integrable? It will say integrate this function. So the one I want to go back to is this complete the square problem, and I won't probably have time to finish it, but I want to at least get you to where you can graph it. And then from 0 to 10, it's going to be a fourth of that circle.
So on the test or final, there won't be an answer. We'll put not integrable.
Integrable. I know, it's a weird word. I'm not saying never because I don't make the final exams, so I would be surprised to see it on there. But I think, yeah, so going through this question, though, it would be all the types of problems you could possibly see in this form, right? So if it's continuous, then it's integrable. Sine of x is continuous, so it's integrable. So then we have discontinuities on the next three. So if it has finite many discontinuities, but bounded, then it's integrable. So this is an example where it's bounded by plus or minus 1, but it has a discontinuity at 0. That's fine. It can have discontinuity. This function doesn't have a discontinuity, but it's not bounded. So it's not integrable.
How is it not bounded?
Because if you tell me any number, I can find a number larger than that. So here if I plug in, let's say I plug in x as a half, then this is a fourth. If I plug in a fifth, it's 25. If I plug in a sixth, it's 36. If I plug in 0.00001, it's really, really large. 0.00000. You see, it goes, if x goes to 0, this goes to infinity. The 1 over something going to 0 goes to infinity. Right? So it's not bounded on the interval from minus 1 to 1. If you look at the graph, you also see that the function looks like this, which is not bounded. And all the other functions are bounded there. Okay, so back to completing the square problem and using geometry. So if I write this, x is between 0 and 10. So this is always positive, right? So I can take a square root of a positive number, no problem. So if I have minus x squared plus 10x. So completing the square, usually we have a coefficient of 1 for x, right? Because I can't get minus x squared unless I have an x times minus x. and I want an x times a quantity something. So I'm going to pull out the negative and have x squared minus 10x. All this is under the square root, right? So what can I add here to make this a perfect square? So it's really 10 over 2 squared, right? So 25. If I add 25, but really I'm subtracting 25, right? So I need to add 25 on the outside. I add 25 here, but since the negative's out front, I'm really subtracting it. So now I can write this as the square root of negative and then x plus 5? No, sorry. This would be x minus 5. X minus 5. Because x minus 5 times x minus 5 would be x squared minus 10x plus 25. Right? So then I have plus 25. This is what y equals. Right? And we said x being between 0 and 10, this is always positive. So y has to be positive if I say y equals that. So then if I square both sides here, I have y squared equals minus x minus 5 squared plus 25. So that tells me y squared plus x minus 5 squared equals 25. So this tells me this is a circle centered at 0, 5 with radius 5. Right? This is a circle center at 0, 5 with radius 5. Do you guys remember that formula? Y minus h squared plus x minus k squared equals r squared. So the center is at h comma k and the radius is r. So from completing the square, I got that the graph of this function is this what I want. Let me think about this for a minute. If I plug in y is 0, sorry, I switched these. This should be 5 comma 0. So this would be k comma h. I think I actually switched where h and k goes when you normally memorize it, but does that make sense? I should probably have a k here and an h here to get it in the exact form books publish it, but
That makes sense. That's
yeah. So if I plug in x is 5, then y would be 0. Wait, now I'm going back to my original representation. I think I am right the first time I did that. So this would be 0 comma 5. If x is 0, then y has to be 5. Y squared is 25, and that equals 25. Right? So 0 comma 5 is my center.
Isn't it 0 minus 5 squared though? Since x minus 5. And that'd be 25, wouldn't it? So 25 plus 25.
Yeah, so if x is 0, 5, okay. If x is 0, yeah, then y has to be 0. So back to my third time I changed it. Yeah, I'm switching my role of x and y. So we can Google. Google's never wrong.
X minus h plus y minus k.
Okay, I switched the role of x and y. Okay. So
It is hk for this time.
if this, so it's our center is actually kh, the way I wrote it.
Yeah.
Okay, so then this would be 5 comma 0, which if x, yeah, because this is x comma y, right? If y is 0, if x is 0, then y would be 0. If x is 0, then y would have to be 0. That's just a point. 0, 0 is a point, and my center is at, if x is 5, y would actually be 5. So 5 comma 0 is my center. Yeah. So 5 comma 0 is the center. So it wouldn't fit this equation, right? Because it's not on the outside of the circle. So 0, 0 is a point, right? So if I plug in y is 0 and x is 0, that's a point on my circle, right? If I plug in y to be 5, x would be 5 as well, right? So 5, 5 is also a point on the circle. 5 minus 5 is a point, and so it's a circle centered at 5, 0 with radius 5, right? This is 5. So that doesn't look like a circle, but let's pretend that's a circle. So if I'm integrating from 0 to 10, keep in mind it's only the positive region, right? Because this function, the square root has to be a positive number. So I'm looking for this area, which is the area of a semicircle with radius 5. So pi r squared over 2. So 25 pi over 2. It's more like a smushed circle, but does that make sense? Sorry for the fumbling the way through the equation of a circle. Question?
The other 25 on the square root.
This 25?
Yeah.
Okay, so I added 25 here. I can't change the problem, so I need to subtract 25, right? But really, I added a minus 25. So I need to also add another 25 under the square root, so I don't change it. So I don't change the original equation. I can add 5 and subtract 5 without changing the equation. So by completing the square, I put in 25 here, right?
Yeah.
But really, I subtracted the 25 because the negative was out front.
Okay.
So I needed to add in 25 so I don't change the relationship that I originally had. But I needed this so I could write it in this form so I could get my center, even though I painfully went around it.
Okay.
That's what you have to do with completing the square.
It's important to remember the formula of a circle.
No, not really. So, I mean, if all else fails, you know that this is a circle with radius 5. That's all you kind of really need to know. If I was integrating from 0 to 5, you would need to know that it was a quarter of a circle. 0 to 10, I'm integrating a complete circle. Or half a circle, sorry, a semicircle. Okay, so that's really the rest of 5.5. It's all just kind of being able to graph something. Like this example is, can you graph the line 4x plus 7 and integrate that from 0 to 3? So can you find the area underneath this curve? 5.6, Riley doesn't like the back button. 5.6 is the fundamental theorem of calculus, which we introduced yesterday. And 5.6 is now, can you, we did this example in class here. So let's go to 5.6. 5.6, this is number 17. Can you integrate from 16 to 25 5x times the square root of x dx? So there's no way I could graph this and get rectangles or triangles. So the only way to approach this is the fundamental theorem of calculus. The fundamental theorem of calculus stated if I can find the antiderivative, I can plug in my upper bound minus my lower bound, I get the area underneath this curve. Right? So if I rewrite this, 16 to 25, what's x times the square root of x? X to the 3 halves dx, which would be 5 times x to the 5 halves over 5 halves, right? My upper bound 25, my lower bound 16. So really what I have here is 2x to the 5 halves, right? So I have 2 times 25 to the 5 halves minus 2 times 16 to the 5 halves. This would be 5 to the 5th power minus 2, 4 to the 5th power. So whatever number that is, just plug it in our calculator, right? We get the area underneath that curve. So we can say 5 to the 5th power times 2 minus 4 to the 5th power times 2 or 4202.
On the test, do you want us to write like units squared or?
No. Nope. So you can see the solution here. Pretty much go through, plug in the upper bound minus the lower bound, and you get your answer. So the fundamental theorem of calculus is pretty powerful. You might need to plug in pi over 4 to a trig function, but that should be pretty straightforward to do that. We've integrated, what's the integral of what's the integral of 6 e to the x? It's 6. It's 6 e to the x, right? Because the 6 is a constant. It's not the integral of e to the 6x. If it was the integral of e to the 6x, it would be e to the 6x over 6, right? But this would be 6 times the integral of e to the x, which is 6 e to the x. So you plug in 3 minus the plug-in when you plug in ln of 3. And then whatever you get with that would be the area underneath that curve. The absolute value. Let's talk a little bit about this absolute value function that comes up in fundamental theorem of calculus. So let's see where I'm at here. We're going to talk about this absolute value function later on, but when you're integrating the absolute value of a function with respect to x, let's say you're doing that from a to b. You have to break up this absolute value of x. You can just drop the absolute value of x when f of x is positive. Right? When f of x is positive, the absolute value of x is f of x. When f of x is negative, to drop the absolute value, you multiply by a negative. And you can drop it. So you can drop the absolute value. You cannot integrate an absolute value. You can't just drop it and integrate the function and apply the fundamental theorem of calculus. So if they're asking you to integrate the absolute value of a function, you find out if the function is positive on an interval, you replace it with f of x. If the function is negative on an interval, you replace it with minus the quantity f of x.
So you're saying at points?
At on the interval. So let's just assume here, let f of x be positive on a to c, and let f of x be negative on c to b. So if I went to evaluate this integral from a to b, the absolute value of f of x dx could be broken up as a to c of f of x dx plus the integral from c to b of minus f of x dx. We will do an example of this in 5-7.
Do you mean B or B?
I mean b. Sorry. B here. B here. Sorry about that. So C is some point in the interval in which they change signs, right? The function changes signs. So if you wanted to integrate the absolute value of this, you're going to integrate the original function on the interval in which it's positive, and then minus the original function on the interval in which the function is negative. This is related to total area on 5.
I have a question. Is the integral from B to A? So how come that you have C?
C is in between it. C is the point in between A and B. So this is related to total area, which will be related to total distance traveled when we talk about 5.7. So if I have a function that looks like this, so if I break this up from A to B, right? So this would be C. Oh wait, sorry. Let's say this is B. Right? If I want to integrate from A to B, I'm going to integrate from A to C plus the integral from C to B, but negative of that because it's below the x-axis. So if this is f of x, another way to write f of x, the absolute value of f of x, this would be the absolute value of f of x. So let's look at it in an example. Question?
Absolute value, would we just be subtracting it?
Yes. You would actually just be using the fundamental theorem of calculus, and fundamental theorem of calculus takes that into account.
Okay.
So you wouldn't do anything different. You could come up with a negative area and be fine.
All right.
That just means your function is more below the x-axis. So let's look at an example of this total area idea. Let's find the area underneath the curve from 0 to 2 of the absolute value of 1 minus x squared dx. So if I look at the graph, this is a quadratic, shifted up 1 and reflected in the negative direction, right? 0, 1, 2. Right, so let's say that goes down here. If I want to integrate the absolute value, I'm going to have to break this up on the intervals, the interval in which the function is positive plus minus the integral in which the function is negative, right? So the function is positive from 0 to 1. So this is going to be the integral from 0 to 1 of 1 minus x squared dx, right? Because I can just drop the absolute value because it's positive. Plus from 1 to 2 of minus 1 minus x squared dx. You can pull the negative out front and take this integral minus this integral because this integral is going to be negative. Or you can distribute the negative in it to make the integral positive. Do you see how we break this up though?
So I thought you said it's like a quadratic graph.
This is a graph of a quadratic shifted up 1, reflected.
The 2 there. How
The-
do you get it to the 2?
So I didn't graph this, great. It should be more like this. So this is 0, 1. If I plug in 1, I get 0. If I plug in 0, I get 1. If I plug in 2, I get 3. I get minus 3, right? Well, I actually get 3, but if I come over here, this would be 2, 1 minus 4, which is minus 3. So I'm looking for this area, and I want to add it to this area because I'm looking for the absolute value. Really, this is like this. Right? If I wanted to graph the absolute value of 1 minus x squared, this is just 1 minus x squared. The absolute value of 1 minus x squared looks like this. Right? It's flipped, it's always positive. So this would be minus 1 and 1. So if I do it this way, I want to find this area plus this area. I can find this area and this area, which make it positive, and add them together. But a way to show that, breaking that down, looks like this. Right? I replace the absolute value of x with where it's positive, I can just drop it. You cannot just use the fundamental theorem of calculus dropping the absolute value, because you're going to come with a negative area. And you know that is not to be true when you have an always positive function to have negative area. So you have to break this up into intervals in which the function is positive and intervals in which the function is negative.
You have to graph that.
You don't necessarily have to graph it. You can say it is 1 minus x squared. When does that equal 0? Equals 1. So x equals plus or minus 1. So then you could have a number line at 0 and 1. This is positive and this is negative. The function is, right? You wouldn't necessarily have to graph it. You could just say, when's this function positive? Set that equals 0 and test points within that interval.
Is that your answer?
Well, I would actually need to integrate it.
Okay.
And then, right, so then I would have x minus x cubed over 3 from 1 to 0 plus minus x plus x cubed over 3 from 2 to 1. So then I would go in and plug whatever this would be, 1 minus 1/3 minus 0 plus minus 2 plus 2 cubed over 3 minus minus 1 plus 1/3. See how I'm really careful with my negatives and where that goes? This is the antiderivative at 2 minus the antiderivative at 0 plus the antiderivative at 2 minus the antiderivative at 1, right? So I plug in 2 minus plug in 0 plus plug in 2 minus plug in 1.
Was it a 1 minus 0?
Yes, thank you. This should be 1. Yeah, 1 minus 0 and then 2 minus 1. Thank you for that. So this is really leading us to 5-7, which is rectilinear motion revisited using integration. So rectilinear motion revisited using integration. This chapter is useful in finding position and velocity by integrating. So if you recall that velocity is the derivative of position, right? So if I differentiate with respect to t position, I get velocity. Right? So then if I integrate with respect to t velocity, I get position. Right? Derivative and integration are inverse properties. So here this is saying if I integrate velocity with respect to t, I get position. I get this position plus c, right? So this is a family of position functions.
You're saying because of the plus c?
Yeah, because of the plus c, I get infinitely many potential position functions. If you want to solve for c, you must be given initial condition, initial position. So that would be represented as s of 0 equals some k, right? So then you plug in at t equals 0, the position is k. right? So what this represents, your book shows this as curves. So if I can put this on here for a minute. So if I add c to a function, and if c is positive or negative, that just shifts that function up and down the y-axis, right? So this is a family of solutions. Given the velocity, the position can represent any one of these curves. And you will need to find the specific curve that gives your initial condition. So at time equals t naught, my initial position is this position. So given that velocity, the particle needs to follow this specific position curve. Does that make sense? So you always have to be given an initial condition. So in the last 4 minutes here, I'm going to go ahead and write the next component of this is if I differentiate velocity, I get acceleration, right? So if I integrate acceleration, I get velocity. Again, same thing. This is some initial velocity. So if you recall back in the rectilinear motion chapter, we talked about displacement and total distance, right? So displacement is going to be when you so displacement from t naught to t1 is going to be the integral from t naught to t1 of velocity. Right? So another way to write velocity is the derivative of position. But the integral and the derivative cancel each other out, so really I have the change in position. Which is exactly what we would expect, right? Displacement is the change in position. And you integrate that. If you integrate velocity and on the upper bound minus the lower bound, you get the change in position, which is displacement. Total distance traveled the distance traveled is going to be from t naught to t1. So I integrate t naught to t1 of the absolute value of the velocity with respect to t. Which we talked about, how to integrate the absolute value. Which would be the exact same concept you did in the rectilinear motion chapter. You need to find when the velocity is positive and when it's negative. Break it up on those intervals, and then you do the absolute value of your displacement on each interval. And that's what it's going to end up being here. So we're running out of time. So next time, we're going to do an example. And we're going to look at the velocity of t squared minus 2t function, and we're going to find displacement and total distance traveled. On the interval from 0 to 3. So I just kind of wrote that there for me, really, to know next time this is where we're going to start off at. So, yeah, if you integrate acceleration, you get velocity. If you integrate velocity, you get position. But you can't get, the only way you can get acceleration is by differentiating velocity. So I can give you velocity and ask for position. Integrate it to get, if I give you velocity, you integrate it to get position. But if I give you velocity and ask for acceleration, you differentiate it. Minus cotangent, yes.
Okay. It showed your derivative, your integration, and then the answer sign.
Right. 1 over okay.
1 over sine is cosecant.
I thought.
So the integral of cosecant squared is minus cotangent.
Right.
It's like there's no way you can do that without integrating by part.